An authenticating proxy in Kubernetes servers as an intermediary between clients, user or applications, and Kubernetes API server, handling authentication before requests are forwarded to API server. This approach allows Kubernetes to delegate authentication to an external system or service, such as OAuth, SAML, LDAP, or custom authentication mechanisms, making it adaptable to various authentication needs. Now let's understand how an authentication proxy works. There are few steps which are required. First is that proxy setup. The authenticating proxy is positioned in front of Kubernetes API server, intercepting requests from clients. It authenticates these requests using a configured method and if successful, forwards the authenticated request to API server. Next comes authentication header. After successful authentication, the proxy adds specific HTTP headers such as xremote user, xremote group that contains the identity information of user or the client. Third is API server trust. The Kubernetes API server is configured to trust authenticating proxy, reading the identity information from headers added by the proxy for authorization decision. Now let's understand with an example. In this one, we will be using Nginx as authenticating proxy with OAuth 2. So first step is that install Nginx. Deploy Nginx to act as reverse proxy in front of your Kubernetes API server. Second step will be configure Nginx for OAuth 2.0 authentication. Set up Nginx to authenticate requests using OAuth 2.0, connecting to an identity provider like Google, GitHub, or your organization OAuth provider. Let's say if you have to look for a snippet of how it will look like, then we can just observe it once. So here if you say location will be auth request slash auth, uses the auth endpoints for authentication. If any error, it will be redirected 401. Next comes proxy pass. This will forward to Kubernetes API server. Then if we see the location here will be auth and then proxy pass, it will be auth server handling auth tokens. If in case of any error or anything, we have to redirect it to whatever will be your host URI. If anything, if unsuccessful, it will be redirected to your host URI. In this setup, Nginx uses auth location to check authentication. If user is authenticated, Nginx add identity headers and forwards the request to Kubernetes API server. Now in step 2, what we have to do is the setup API server flags. Configure the API servers to trust the proxy and accept identity headers. This can be done using below commands. So we are allowing front proxy client and then the extra headers xremote extra, xremote group, xremote users. These flags ensure that API server recognizes and validates the header from proxy. Now comes the secure communication. Use TLS to secure communication between Nginx proxy and Kubernetes API server, ensuring that identity information remains confidential and unaltered. Now comes the third, access Kubernetes API. Client request flow first will be client sends a request to Kubernetes API server through Nginx proxy. Second will be authenticating and forwarding. Nginx authenticates the request, adds all the required headers, and then forwards them to API server. Third one is authorization in Kubernetes. The Kubernetes API server uses identity information from header, xremote user or xremote group for authorization check and process the request accordingly. Now let's understand how it is different from its peers. Unlike other authentication methods that require direct integration within Kubernetes API server like webhook token authentication, authenticating proxy offloads the entire authentication process to an external service, reducing complexity within Kubernetes. Flexibility with external system. Authenticating proxy is highly flexible, allowing Kubernetes to integrate seamlessly with wider range of external identity providers and authentication protocols. So in a summary, authenticating proxy offers a versatile and powerful approach for Kubernetes authentication, especially in environments where integration with existing enterprise identity solution is crucial. By handling authentication externally, it simplifies Kubernetes internal security setup and offers extensive adaptability with various authentication